We are live.
Okay, I'll introduce them. Welcome everyone to Machine Learning Research Week. Thank you for tuning in. I am Bhavnik. I am the Natural Language Processing Head here at itg.ai. And for today's talk, I would like to introduce you all to Dr. Martin Henze, also known as Heads or Tails. He has a Ph.D. in astrophysics from Technical University of Munich, which is a globally renowned university and one of the best in physics. He currently works as a data scientist at YipitData, and I'm not sure if everybody here knows about his Kaggle identity, Heads or Tails. He's the world's first notebooks Grandmaster and a current 2x Grandmaster. And he has 23 notebooks with 23 gold medals, which is just an amazing achievement. I'm pretty excited for this talk. Hope everyone watching this is too. Over to you, Martin.
Thank you. Thank you for the kind introduction. Hello, everybody. My name is Martin. I'm known as Heads or Tails on most of the socials, including Kaggle and Twitter, which are the places where I hang out the most. And I'd like to talk to you today about effective exploratory data analysis, or EDA, and data visualizations. So we're going right back to the basics and looking and focusing on the data. So why are we doing EDA in the first place? Why should we bother with all of the things that I'm going to talk to you about in the next hour? Well, there are several reasons for it, obviously. Why shouldn't we just, throw our data in the model, see what comes out of the model, and then, take that? Why should we look at the data in the first place? And in order to, answer that question, let's think a little bit about what a model is. So here we have this very simple classification problem, and we have this support vector model, which very neatly separates the red points in the lower end from the blue points in the upper end. And, it's a perfect separation, it's a perfect model. And in most cases, pretty much all cases in real life, your separation will not be as perfect, and, your model will have to struggle a little bit more to come to an outcome. But one thing that we should always remember is that every model is a simplified description of your training data, right? That's what a model is supposed to do, and that is its strength, that a model takes your training data and finds in it the patterns that matter, the patterns that are generalizable, ignores those patterns that you don't want, that don't want to overtrain on, and then gives you a generalized idea about your training data that then hopefully you can apply to new future data in order to make predictions. Right? But the model stands and falls with the data that you give to it. And if the data is bad, then the model will be bad. So garbage in, garbage out is a very fundamental principle, right, in all of science, including data science or machine learning. You cannot expect a good model from bad data. And that's why it's important to explore your data, to know what kind of data you're dealing with, and to find out the strengths and the weaknesses of your data sets so that you know whether you can trust your model going forward or not. And there are different angles, different aspects that we can look at when it comes to exploratory data analysis and to garbage in, garbage out. And this is the first aspect. We'll be looking at a very kind of real-life practical example, which is the infamous United States 2016 election, where all the polls before essentially were saying that the later President Donald Trump will not win because the polls were in favor of the Democrats. But then Trump consistently outperformed these polls in the key states, and all the sophisticated model that the pollsters had been building, they fell down and they failed. And that was likely because the polling methodology that had been used in this election and the way that people responded to the polls, the questions they were asked, and the way that they answered these questions did not favorably compare to the previous elections where the model had done very well. So something had changed in the data, and the models weren't aware of that because that change wasn't factored in, and so they failed, and they failed quite dramatically. Right, so this is an example for what goes wrong if you get new data and there's a change in your data over time, and your models don't know that there's a change and they can't deal with it. So this is an example of bias in your model, and bias will always be there in some shape or form, either conscious or unconscious. And another relatively well-known example is in computer vision. If you're training a vision classifier to find skin issues, like possible skin cancer, right, which is a serious problem, and your training data set only includes people with light skin, then your model will do not very well on people with darker skin, or vice versa. So you have to take into account all the possible parameter space that your model will encounter in production, in real life, in its predictions, and include that in your training data so that your training data is representative. And you should think very hard about all the possible sources of bias that there could be. And in addition to that, of course, you should always consider the ethical implications of your work, right? Because some of these biases, they can be severe and they can affect real people in real life, and they can lead to these vicious feedback loops, right? When it comes to very questionable applications of machine learning, like predictive policing, for example, which is a very hot topic, or even the YouTube algorithm, right, which has been found to lead people down rabbit holes of radicalization, just for improving the number of clicks. So there's an ethical aspect to our work that we should not ignore, and that we should always be aware of. And one way to find out more about these ethical aspects and which parts of life the model will eventually touch on is to talk to domain experts. Right? Domain expertise is something that's important, and that's often overlooked when we talk about building machine learning models and machine learning applications, partly because the field is so new, and the field being so powerful is even newer, that we might often think we can get away with reinventing everything from neural network first principles, while we might not be aware that there is a large body of work that has already been done excuse me, by other researchers, by social scientists, by linguists, by political researchers, that we should be aware of when we build these models, so that we can build them on a foundation that is secure and robust. So domain expertise is important. And these examples of bias are numerous, right? You can find them frequently in the news cycle. You can find them frequently in anything that comes up, like recruiting tools that show bias against women or other parts of society, like this infamous de-blurring tool that turned a picture of the US President Obama into the picture of just a generic white guy. Gender bias and automobile safety is costing women's lives. And this is, this transcends the realm of software and machine learning models. It goes into hardware as well. This is not even self-driving cars, but self-driving cars have, their own very, very complex ethical and bias problems. So all of these things are out there. And for many of these things, there are solutions already out there that are provided by domain experts. And talking and collaborating with these domain experts will bring a very valuable angle to any of the work that you do on machine learning models. So bias is something to keep track of. Before we go to the next aspect, so we'll have time. We have plenty of time after the talk for questions, but I'm also happy to take questions during the talk. So if anything comes up to any specific for any specific topic, we can talk about it on the fly. And there is a certain flow to the presentation, but I'm relatively optimistic that I can pick up the flow again after the question. So feel free to ask anything you'd like me to ask. Now, on to the second aspect that I would like to talk about, why EDA is important. Here is an example that is very famous in statistical circles, but not everyone in data science or machine learning might know it. It's called Anscombe's quartet. And you might think that you don't necessarily need data visuals. You can just extract some overall statistical characteristics of a data set, like the mean, for example, the median, the variance, some correlation coefficients, maybe even fit a linear fit to figure out whether it's going up or down. But Anscombe's quartet is designed in a way that all of these four facets that you see here, they have exactly the same characteristics. They have the same mean in both of the variables. They have the same variance, the same correlations, the same fits. Everything is exactly the same. So if you don't visualize your data set, then you might be led to mistake that all of those four plots are identical, whereas obviously, the upper left is very well behaved. The upper right is clearly not a linear relationship, and the other two show some very strong outliers and some, very strange characteristics that you would definitely want to investigate when you're dealing with this data set. So always plot your data. If you're taking anything away from this talk, it is always plot your data, always look at your data, because data visualization will immediately reveal any features like outliers, skewness. You might already see some missing values. You get an idea about data transformations, and it will reveal gorillas in your data. So hang on, did he just say gorillas? What are gorillas? Well, sometimes there are cases like this. So this was a psychological experiment, essentially. I found that on Twitter. It's a really nice story that I'd like to tell you about. And students were told to analyze a data set to test a specific hypothesis, right? So you see that there's body mass index there's steps, there's male and female. So it has something to do with, weight loss or weight gain, or probably something like this, or fitness. But a lot of the students, they didn't plot the data. They just kind of fed it into models, and they didn't realize that when they plot the data, there was literally a gorilla sitting there just waving out at them, right? And that was the real experiment, whether the students would notice this quite remarkable feature in the data or not, or whether they would just go on with their models and completely overlook it. Now, you might rightly think that not many data sets out there in the real world will contain a gorilla in the first place. And, you might be right, although I haven't checked them all. I can't say that there aren't any gorillas out there. So it's always good to make sure. But data visualizations will immediately show up a feature like this. It will show outliers and skewness, like I said. And a more realistic example that you'll encounter in the real world would be a distribution like this here on the upper left, which is very skewed. It could be the distribution of a target, like a price or something that you want to predict. And whenever you see a distribution like this, then your immediate thought should be, let's try a transformation. And the transformation that suggests itself here is a logarithm. So if you apply a logarithm to this data, you find out that the outcome is normally distributed. So this is a log normal distribution, which is quite frequent in nature and in people's behavior as well. And the normal outcome that you get has now much better statistical properties, and you can deal with it in a much more rigorous way. Now, all of this is about some sort of tabular data, right? Although, normal log normal is also relevant when you think about a prediction target, for instance. But always plot your data can be generalized to always look at your data. So another thing that I saw recently on Twitter, and you see I spend quite a lot of time on Twitter, but at least some of it is useful, is this post here by someone who points out that computer vision researchers rarely look at the individual data points, right? Maybe too lazy, maybe have the right tools. But now there is a tool, and he promotes this tool from the TensorFlow team called Know Your Data. And I think there are a few tools like this out there that would allow you to say, okay, I want to find all the pictures in my data that have a cat and a keyboard on them, right? And for anyone who has a cat, you won't be surprised that there are a lot of these pictures because, as we know, cats, they love to sit on everything and sleep on everything that they're not supposed to. So keyboards are always a good choice. Or, you can look for all the pictures that have a boat and a firework in them. And that will, of course, also automatically reveal whenever something is misclassified, right? If you base this search has to be based on a model. If your model is getting something wrong, right? If this would be not a cat but a dog, then just looking at your pictures will immediately show you. Looking at your pictures also immediately shows you, that there's certain angles to the cat pictures. Fireworks are obviously taken at night. That's not a big surprise. But it will tell you something about the pattern that the model looks for when it identifies fireworks. So there's really no excuse for anyone not to look at their data. And all the kind of tools and strategies that I'm going to talk to you about today, they can be generalized across different data sources, right? Tabular data is the most obvious one. Image data, you might even think is more obvious because they're images. So, you're supposed to look at them, but few people do. And often you have a very large data set of images, but, at least look at a few, look at some examples, see whether something's going wrong, right? Maybe some of the cats are flipped upside down or other issues are going on, right? You'll find those very quickly if you just browse through your data a little bit and have a look. And so tabular image, text data is, of course, much closer to tabular data because text can be tokenized, and you can look at word frequencies, you can look at the length of your text. You can, if you just read through some small excerpts of your corpus, you will see whether there are immediately some issues jumping out at you with formatting issues or common misspellings or something like this. So always look at your data. The next part of why EDA and data visualization are important is that communication is key. So data analysis, data science, and machine learning does not exist in a vacuum. You always want to show your results to people, and you need to communicate your results to people in order that they can use it. And if you compare something simple like this, an overview table on the left-hand side, to a visualization like this, which was, handcrafted and hand-tuned in order to show exactly what's going on, then, even though the table doesn't contain the same observation, the same exact data, the visualization is obviously more, it immediately captures your attention. It is more captivating. People start asking questions about it, and you can get people to engage with your results much easier. So if these two ways of presenting your data go up head to head, then it's no contest. The visualization wins. And communication is key. We can also look at that from the other side. So if you are experienced in building data visualizations that clearly show what's going on, then I believe you're also getting better at reading data visualizations that you will encounter in the wild and you will encounter in the media and through other ways. So, another example from Twitter, you might be able to start spotting a pattern by now. This person posted something about the situation of COVID-19 in the United States, and it followed this popular how it started, how's it going meme. And the picture from January, how it's going, had all these scary red colors. The whole country was red, and it looked very alarming. And then he said how it's going today, which was like 2 weeks ago or so, and the colors were much less alarming. There were some kind of calming blues in there, and it looked like the situation was much better and it was under control. But obviously, if you look at the scales that were helpfully supplied together with these graphs, then you see that, all the scary red that's here in the left can be fit into this very narrow range of calming blue on the right. So in fact, the numbers were much worse. The situation was much more critical. But if the scales weren't there, then it's very easy to mislead people into thinking, oh, it was dramatic and now it has improved quite a lot and we can relax our caution. So data analysis, data visualization, of course, plays a very large role when it comes to communication of science, when it comes to communication of policies like this. And it can be used consciously or unconsciously to mislead people. And I believe that the more experienced you are in building your own data visuals, and you see which aspects you want to highlight, you want to focus on, the better you get at reading those. And of course, Twitter being Twitter, somebody immediately pointed out, you have hereby been found guilty of committing a chart crime. And yeah, the sentence should be, I don't know, take a semester of data visualization or so, and then come back and do it better. But I'm not in charge of sentencing chart crimes, maybe for the better of humanity. So communication is key, and in many cases, this will not involve Twitter interactions or interactions with the media, but it will be about how your machine learning or data science project is situated in the bigger picture, right? So if we're thinking about industry, then your project will look something like this approximately. Right, there's a data extraction step happening. Somebody from somewhere gets some data and gives that data to you. And then you do your machine learning magic here, and you produce some results. And those results will fit into, or those results will lead into a business case and be used for a business case. Or, in academia, it can be similar. Just, you want to get a paper out of it, or you want to, feed it into a collaboration. All these parts can be abstracted. And within your project, there are certain steps. There's EDA, which is what we're talking about today. Data cleaning is always important because real world data is always messy. It's always messy. And then you have your model, and then you tune the whole thing and optimize it. And of course, this is not a one-way street. There's a lot of iterations happening here. There's a lot of back and forth. And you go from cleaning back to EDA. You go from the model back to EDA to understand some of the model outputs better. And there's a lot of iteration. But generally, it will look something like this. And importantly, in all of these stages, there is you get a lot of value out of communication, right? You want to talk to the people that you get your data from about your EDA findings and about the data cleaning, right? Maybe you uncovered a serious issue in the way that the data is extracted. So you want to go back to them and say, well, maybe we can fix it at your stage, and you can clean this up so that we get better data. Yeah, and if they're nice and if they have the time, then they might do it, and everyone is better off for it. And you're definitely better off for having found it and taken it into account, right? Same for the exploratory analysis. You might find some weird skewness or some biases or some missing values in your EDA and communicate it to them. And there might be some bug or some other issue that they can fix it. And same on the other end of the pipeline, right? So your model is supposed to answer a certain business question, or your model is supposed to answer a certain research question. And in order to figure out whether your project is actually doing that, you want to talk to the people that will be using your model and will be using your predictions, because otherwise there is this danger of operating in a vacuum, and you build something that's very nice and sophisticated, but it's not really answering the question that you were expected to answer, right? Which is suboptimal. So there's a lot of communication happening at all of these stages. There's a lot of communication happening within the model. You just kind of talking to yourself, talking about the model, talking to your teammates about the steps that you're doing and how you could do them better. So communication is key, and communication is very much supported by data visuals and by knowing a lot about your data. So to summarize this part, the first part of the presentation, the four main aspects that I want you to keep in mind is garbage in, garbage out. If your data is bad, then your model is going to be bad. There's no way around it. And that's not just in terms of the data being bad, but the data being biased. So beware of bias. Think about sources of bias in the data extraction, in the data preparation. And bias doesn't have to be intentional. It can be unconscious, but it's just as dangerous, maybe even more. Always plot your data. Always look at your data, because that will tell you very quickly if something odd is going on in your data. And, odd can be bad, or it can be good. Maybe you found some interesting feature that you want to look closer into, or maybe you found that, half of your data is outliers and missing values, and you just need to go back to the drawing board and collect your data better. And, the other part is communication is key. You want to talk to the people that you get your data from. You want to talk to the people that will use your outputs. And you want to talk to everyone. And in order to show and to illustrate what you're working on, you can use data visuals very effectively to communicate your results and communicate what you're talking about. All right, so if anybody has any questions on this part, then now will be a good time. I'm going to take a sip of tea and let me know if there are any questions.
There isn't any question on the chat yet. I had one question, if I can ask that. So my question is essentially that I work a lot in NLP. So you mentioned that you should visualize your data always. So what are some of the visualization methods you can use in NLP that might be beneficial? For example, for data sets like the toxic comment data set on Kaggle, can you do something? It's very unintuitive, I think.
Well, it might be, it might not be, right? So there are some ways in which NLP data can be, text data can be treated like tabular data by tokenizing, and then by looking at token frequencies, for instance. In terms of, in the case of the toxic data, you have a certain target, which is the toxicity. So you can definitely start out by looking at how this target is distributed, because as far as I remember, it's very skewed, right? Fortunately, most comments that you encounter on the internet or in the data sets are not toxic. So this is something that you want to know about when you start your analysis, so that you pick your metric accordingly that you will use in order to judge your model. So this is one part. And then your data itself, you can start by trying to figure out whether there are specific patterns, right? Whether your word frequency is different for the toxic comments or the non-toxic comments. Are there are there very specific swear words or slurs that are happening very often in the toxic comment? And this doesn't have to be words. It can be bigrams. It can be trigrams. It can be phrases, essentially, to see whether there's something specific going on in your training data, and then to figure out whether your test data has those same aspects, or whether there are systematic shifts between the two, right? In a competition, this is something that is just designed by the organizers, and you have to learn more about it to be better at a competition. In the real world, this kind of translates to how representative is my training data when it comes to the applications, the situations that the model will encounter in production in real life, and you want this to be as representative as possible. And one of the very simple things is just to read, to kind of take half an hour and read some random examples from your training data and figure out what is the structure of those comments, how are they phrased, what kind of grammar are people using, and this kind of things. Maybe the grammar in the in the nice comments is different from the grammar in the toxic comments, where people just go on around. And all of this, this is a very low level way of looking at your data, but a very powerful one.
Yes, thank you. That was a great answer.
All right, well, let's go on. If there are more questions, then we'll take them as they come. So we talked about why we're doing EDA. Now let's talk about how we should do it. And this is very subjective advice that you're getting from me. Those are my EDA guidelines that I've been using on Kaggle, that I've been using throughout my work. And in order to illustrate them a little bit better, I'm using 2 of my notebooks from 2 different competitions. One was a playground competition on taxi trip durations in New York City. So how long does it take to take a taxi ride from one part of the city to the other? And I called this notebook The Fast and the Curious. And then there was another competition a little while later where it was about forecasting supermarket sales, essentially. And I called this one Back to Predict the Future. And as you'll see, I like bad puns, but that's just, the nature of it. So here are my guidelines. The first one is you should always understand your data context. And in the case of a Kaggle competition, this is relatively straightforward. You just want to read everything that has been published about the competition by the organizers. So usually there's some context around the competition. There's a data description that tells you about where the data comes from, what the different data types are, right? So, date and time, geographical features, longitude and latitude, and something like this. So you want to read everything. Most people don't, which still surprises me. And then, a couple of weeks into the competition, they suddenly realize, this feature is distributed like that. Well, that's a surprise. Well, it isn't really a surprise because it was mentioned in the data description. And, if you had read it before, you would have noticed it. And so this is for Kaggle, where everything is, of course, prepared and designed. And in the real world, this relates to talking to the people that have produced your data, where your data comes from, right? Because like I said, real life data is always messy. There are always some limitations, some assumptions that go into it. And there might be some oddities in the way that the data is created. And you want to understand the context in which your data was produced so that you can, better understand the data yourself and better understand whether the assumptions under which your data was collected are actually matching with the assumptions that you have for your modeling. The second guideline is just look at your data. And we already talked about this a little bit, but just take, even if it's just half an hour and just look at your data. If it's tabular data, you can look at the tables themselves. You already find that there are, some aspects like feature types. So looking at this data, you see some of those features are integers, some of them are categorical. So you have, states there, you have departments, you have categories, and so on. You might already see some missing values popping up at this stage. You might already get an idea about the order of magnitude of certain features. And like we just talked about, it's very similar for NLP. Just read a little bit through your corpus if it's in a language that you can read. If not, then you might play around with some automatic translations just to get an idea of what your data looks like, what its overall characteristics are. And for images, of course, look at your images. Look at the number of images, maybe the size, maybe the orientation. Maybe some images are darker than others, and your model ends up picking up on the background rather than the actual subject of the picture that you want to model, which would be bad. So just look at your data, look at it, and you'll learn more about it immediately. And then guideline number 3 takes it from there. So always plot your data. After looking at your data, you want to visualize it in some shape or form. And again, here are the examples for tabular data. Depending on the type of feature, you would choose different visuals to start from, right? So for categorical features, there are bar plots. For time series, there is a line plot. So you just kind of plot sales over time in this example here on the upper left. And there are scatter plots. There are different types of plots that suggest themselves for certain types of features. And you want to start out with those. And you want to start out simple. You don't want to go too complex. You don't want to start out with a kind of three-dimensional plot with 5 different colors and kind of point sizes and something like this. This is only going to confuse you. But start out simple and look at each feature individually. Definitely look at the target. Look at how the target is distributed. Right. This is applicable through all sorts of data problems, not just tabular. And then get an idea of how your features are distributed before you go further. And when you go further, and this is guideline number 4, you want to gradually build up complexity. Right? You have one feature that's interesting, another feature that's interesting. What happens if I combine them? Right? So in this notebook, here on the right, the day of the week turned out to be an interesting feature. And the hour of the day turned out to be an interesting feature as well. So what happens if we can combine them? And we can combine them in a heat map like this. So this is about taxi rides, right? If you remember what the competition was about. And this is the kind of the median speed of these rides. And unsurprisingly, you see that, during the week and during the kind of rush hour times, taxis are very slow because there's a lot of traffic. Whereas, during the night, right, between kind of 3, 4, 5 a.m., there's really not that much traffic, even in New York City, and taxis can move much faster. And interestingly enough, this kind of changes a little bit between the weekdays and the weekend. And something kind of a relation like this is not easy to pick up if you just look at the individual features by themselves. But if you combine them, it immediately jumps out at you, right? And it makes intuitive sense. If you remember the time before COVID, people would actually go out on the weekend and, would go to bars and clubs. And then there would be a little bit more traffic at nighttime from all these people being on the road. And this is something that, a more complex visualization will easily show you. Similarly, one way to kind of add an additional categorical dimension to an existing plot, like a time series plot, is to add facets, right? You can have a facet wrap, you can have a facet grid, where you show 2 different categorical features. So here it's the department of this department store and the US state where the store was located. And you can kind of neatly look at them side by side and see, okay, where's the volume of the sales coming from? And what are the differences in growth over time, right? So gradually build up complexity, follow the interesting features and try to set them into relation, with a target and see what you find. And then from there, this is where the kind of the deeper and more complex analysis comes in. You want to look at your data from different angles, right? From different perspectives. So here in this taxi ride competition, to stay with it, our target was continuous, right? We had the duration of the ride in minutes or seconds or something like this. And one way to change the way, the angle you're looking at it a little bit, is to treat it as a classification problem. Just kind of randomly transform it into fast and slow rides by this very coarse binning, and then see how those features interact with other features like the day of the week, or whether it's a trip to an airport. Right, so you can try to give a different perspective by looking at classification problems from a regression perspective, by looking at regression problems from a classification perspective, and see whether you gain anything from that. In a similar way, time series problems, you want to choose a different visualizations to see if different patterns show up. Right, so a line plot shows you how the data is kind of evolving over time. It's the great starting point, the best starting point probably. But sometimes you want to switch angles up a little bit. You want to look at a calendar view like this, right? So those orange days, they're different from the gray days. They are special. And you see that in California, they are distributed like this, just as a, as a block at the beginning of the month. But in Texas, they have gaps in between them, right? And those kind of gaps, yeah, you might be able to, see something strange happening in the line plot. But if you have a calendar view like this, then they are immediately obvious. It's immediately obvious what kind of pattern is going on down here, what kind of pattern is going on up there, and you can adjust your analysis accordingly. So this is the part where it kind of goes a little bit into being an art rather than a science, but you want to switch up perspectives a little bit. You want to look at your data from different views in order to learn more about it. And this is the stage where you really tune into your data and you really learn about its complexities and about its nature, and you start going deeper into specific aspects of the data.
Martin, there's a question. So the question says, what should we do to visualize data with a lot of null values? Should we completely remove them before doing EDA?
Well, there are different strategies of dealing with missing values, right? You can one thing you can start out with just completely removing them and see what the rest of the data looks like. Then you can just count the number of missing values versus the number of non-missing values. Make it a bar plot. See, maybe 40% of your data is missing, and you want to know, more about that. You can turn the question whether your data is missing or not into another feature, right? Maybe that feature interacts with some of the other features. Maybe there's a specific reason of why your data is missing, and that is reflected in some of the other features. And then ultimately, when you feed the data into a model, you want to know how to deal with these missing values, right? You just want to turn them into another class, right? Maybe it's a categorical feature, and it's relatively easy to do that. Do you want to impute them? In many cases, you probably do. What's the imputation strategy that you would choose? And by doing kind of data visualization and seeing how the observations with the missing data compare to the observations where the data is fine, you'll already learn a lot about what kind of imputation strategies could you use and which might be helpful.
Yes, thanks. I believe that's it.
Okay, wonderful. So we have all these 5 guidelines so far, and they kind of are about what you do when you analyze the data. But there's a 6th guideline that is very important throughout this whole process, which is document your thoughts and ideas. And that just means write down what you find, write down why you chose this particular visualization and what you found to be interesting about it, right? Because even in the next day, suddenly kind of a month or 2 later, it might not be as obvious to you why you chose to look at this particular aspect of the data. So you always want to document your thoughts, your ideas. So in my notebooks, I often structure it like this, that I have a visual, and then I write down like, well, what are my insights from this visualization, right? You can also document your ideas that you have throughout the analysis about future interactions that you want to study in more detail. And I saw it being said somewhere, I don't remember where, that the difference between doing science and just playing around is writing things down, right? So you want to write down your findings, you want to solidify and clarify your thoughts that you have about the data, and then of course that will feed into communicating your findings, communicating your insights to other people, but also to yourself, kind of reflect it onto yourself and see whether the thing that you found in the data, the way that it kind of works in your head, actually makes sense when you put it on a page. So those are the 6 EDA guidelines that I would suggest you to follow. I follow them in all of my Kaggle projects, in all of my work projects, and they have to be, aspects of them have to be adjusted according to the data set that you're dealing with. But broadly, I think they will serve you very well, and they will kind of get you a lot of insights, and they will allow you to streamline and to optimize your process. Now, if you haven't much experience in exploratory analysis or visualizations or Kaggle for that matter, then here are some suggestions from me as to where to find inspiration and where to find ideas about EDA and about anything really. So I've been working on this weekly series, which I'm calling Hidden Gems. And the purpose of the series is to highlight notebooks on Kaggle that I consider underrated. So that includes, that essentially means that the content is great, the presentation is great, it's a great notebook, but for some reason it didn't get the attention and the praise that it deserves. And I want to, give that attention to the notebook authors, and I want to give them the motivation and the encouragement that their work deserves. And every week I'm publishing 3 notebooks that are chosen by me very subjectively as being underrated, and I highlight them for the rest of the community to take a look at them because I think that people will get a lot out of it. And we are getting close to episode 100 of Hidden Gems, which is going to come in April. And there is, already a very kind of a large enough set of notebooks that you can look at and you can get a lot of inspiration from, in my opinion, about EDA best practices, right? Always interpret your findings. If you structure your notebook like this, right, you have this little points to note here, then, you make it much easier for the readers and for yourself to pick out the insights that you want them to notice, right? In a similar way, narration. If you write a notebook like this, then, having a narration aspect is also important for keeping the reader engaged, and also for telling yourself how you moved from one aspect of the analysis to another one and why you're doing what you're doing, which might not be obvious in hindsight. And if you're building visualizations, then you want to always start out with something simple, but sometimes you want to build really kind of sophisticated and engaging visuals, and that takes some time, takes some effort, and takes some expertise. So here, this author, who has a lot of great notebooks on Kaggle, he took a very complex data set, right? So all the flight routes for commercial flights in the United States between the different airports. And you can see that there's a lot happening in this data set. This data set is very busy, but you're able to clearly distinguish the green lines, the red lines, the orange lines. You immediately see which airports are busy and which airports are less busy. And it's a great way, in this map visualization to give you an immediate intuitive impression of your data. So if you're crafting engaging visuals, you have a very strong mode of communicating, right? In a similar way, you sometimes find these kind of visuals in underrated notebooks that they wouldn't look out of place in a scientific article at all. In fact, I've read articles on science or in Nature, on high impact journals like this, where the visuals weren't nearly as well crafted. So here the author takes really extraordinary effort and puts extraordinary thought into their visuals to communicate what's going on. And this is about the CO2 increasing over time, and it's related to climate change. And the same author always gives us a good example for how to introduce your work, right? You want to start out with an introduction that captures the attention of the reader. And this is true not just for Kaggle, but for any reports that you're writing at your work, for any papers you'd be writing, or for a thesis that you would be writing, right? None of these things just exist in a vacuum, and none of these are just about the pure results. But the narration is important, and how you introduce and present your work is important, right? You can start with a nice image. So this one is about chocolate. A lot of people like chocolate. So you'll kind of want to, engage the reader from the beginning and draw them into your analysis to keep them interested. And you might even go as far as setting up your methodology as a little flowchart, right? So you see that this includes a lot of what we talked about: data visualization, data preparation, and here this author also took extraordinary, went to an extraordinary length in order to communicate their methodology, right? So if you put something like this in your thesis, for instance, or in another presentation of your work, then it will be much easier for the readers, for the audience, to understand what you're talking about and to follow your findings and to follow your results. You want to structure your work very well. You can use, different strategies to do that in an interactive notebook. And finally, to trace an arc from the beginning to the end of this talk, which is happening now, is you can study your model itself through data visualization. So this is a criminally underrated notebook on Kaggle, still, even after being featured in my Hidden Gems, where the author takes us on the journey of an image through a neural network. So this is about the MNIST data set, obviously. So it's about the digits, and he really puts a lot of effort into visualizing how the particular observation goes through the model, what the model does, what a convolutional layer does, and you have the flattened layer, and then you have the output. And he even includes projections into the two-dimensional space from the different stages of the model, so that you can see how well the different input digits are separated at each of the stages. It's remarkable work, and it will help you a lot if you're just kind of getting into computer vision, or even if you're more seasoned in computer vision, to give you ways in order to understand what's happening inside your model through data visualization. So all of these gems, hidden or not, you can find on Kaggle. You can find a lot of inspiration there. A lot of smart people are producing a lot of great content, and I really encourage you to check out the community, check out the platform, and learn more about exploratory data analysis and data visualization. And thank you very much for listening.
Yeah, that was definitely a great presentation. There was a comment by Andre Lukinenko. He's also a Grandmaster, and he says, "This is a great hoodie."
Thank you.
Yeah. And I believe a lot of people were interested in this, and they might have had questions, but because of timing issues, they weren't able to catch this. I believe they'll catch it on YouTube later. So is there any way to contact you? Maybe through Twitter?
Yeah, Twitter is a great way. Just tweet me your questions, include a link to this so that other people kind of know what you're talking about as well, and we'll try to answer any questions, anything you want to know about EDA and data visualization.
That's great. A lot of people in the comments as well said it was a great presentation, and they definitely got interested in making better visuals. So yeah, I hope everybody who's watching this video. Oh, a question just came in. If you don't mind. Also, it says, since you have a PhD in astrophysics, do you use EDA for that purpose as well, and any quality data sets relating to astrophysics?
I definitely used EDA for that. So that was my previous life. I started out in astrophysics. I spent a good decade doing astrophysics research, and my work was observational. So I would get data from a telescope, and then I would analyze this data to study the physics of the objects that I was observing. And EDA in that case meant that there was a lot of kind of data cleaning involved. because I got data from telescopes in space, and telescopes in space, they have their own oddities and quirks. So you wanted to clean the data very carefully. And then a lot of the EDA I did on the kind of reduced and extracted data as well, right? So I would like look at the brightnesses of stars in my images and plot their distribution. I would look at correlations between things like the energy that I would get for that particular star and its brightness over time. Time series were a big aspect of my work, since I was looking at variable stars, and time series analysis like this, periodicity analysis, finding trends, finding outliers. And for all of that, I found EDA to be extremely useful.
Any quality data sets in
astrophysics? Yes. So the one interesting thing about astrophysics that not many people are aware of is that a lot of the telescopes that we have in space or otherwise, they are publicly funded. And publicly funded means that their data will be publicly available sooner or later, right? Sometimes there is a period of maybe a year or so where the principal investigator of the project has exclusive data rights, but even then, afterwards, it becomes public. So NASA, for instance, has a lot of public databases from space telescopes or other telescopes. Like I was working with X-ray telescopes called XMM Newton and Chandra, and Swift. And Swift is a great example because Swift is a kind of little, very powerful telescope that can observe in the optical and X-rays and gamma rays. And all the data that Swift gets are immediately available for anyone out there in the world. You just need to find the right place, go download, and you can analyze that data. So there are a lot of places out there through organizations like NASA, through organizations like ESA in Europe, where you can just go and download data from a space telescope. You don't need to ask anyone for permission for that. It's just free for anyone. And you can do your own analysis with it.
Wow, that is definitely great. I might just go download it right now after this talk. So with no other questions, I think we will end this talk. If anybody has any other question, I hope you contact Martin on @heads or tails on Twitter. And definitely check out his Hidden Gems series on Kaggle. That'll definitely help you in your EDA and your Kaggle journey as well. Thank you everyone for tuning in. We will end the live stream.
Thank you. Thank you for having me.